Hello, I am Muskan from Cheenta. You might have come across the sum of terms of arithmetic progression as n by 2 into 2a plus n minus 1 into d, where a is first term and d is the common difference. Also, the sum of terms of a geometric progression is a times r to the power n minus 1 by r minus 1, where a is the first term and r is the common ratio. There is a very interesting series known as Arithmetico geometric series, that is a combination of arithmetic and geometric progression. Today we'll see a question from ISI M.Stat 2017, problem number 11. We'll go through how we derive the formula for summation of arithmetic progression and geometric progression and use the same concept to solve that question of infinite elements. A is the first term of an arithmetic progression and d is the common difference. Then the sum of all the elements from 1 to n, also denoted by Sn, is equal to a1 plus a2 plus a3 all the way till an. Since summation is commutative, we can change the order and write Sn as an plus an minus 1 plus an minus 2 plus 1 till a2 plus a1. And the reason we are doing it is, we will see in a minute, this is a very beautiful relation. Let's add these equations. On left hand side, we'll get 2 times Sn is equal to a1 plus an, that is a plus n minus 1 times t. Then we have a2 plus a of n minus 1, that is sum of second and the second last term, plus t plus a plus n minus 1 times t, and so on. In the last term, it will be same as the sum of a1 and an, that will be same as a plus n minus 1 into t. If we observe carefully, these all are same and equal to twice of a plus n minus 1 times t. It is a very beautiful relation that the sum of terms starting from beginning, let's say the first term and the last term, sum of it is same as second term and the sum of first, second and the second last term. The sum of third and the third last term, sum of fourth and the fourth last term, they all are same and equal to 2 times a plus n minus 1 into d. Now we can see that these terms are repeated n times. That give us the relation that sum is equal to n by 2 is equal to 2a plus n minus 1 into d. This is for arithmetic progression. Let's see how we can find the sum of a geometric progression. The terms of a geometric progression are a times r squared, so till a times r to the power n minus 1, that is the nth term. Now since we have to find the sum of it, let's write it as Sn is equal to a plus ar squared all the way till a times r to the power n minus 1. Now summation technique is a little bit different in case of geometric progression, and we'll use the same technique to find the sum of Arithmetico geometric series, that is multiplying the whole equation by r, that is a common ratio. So r times Sn is equal to, and now multiplying a with r, we get ar, then ar squared, so the last term will be a times r to the power n. Now we subtract these two equations. And it forms a series known as telescoping series, where the common terms are getting cancelled out and we'll be left with only two terms, that is a and a times r to the power n. And on the left hand side we have 1 minus r times Sn. So the formula for summation comes out to be Sn is equal to 1 minus r to the power n times a over 1 minus r, or we can change the sign and write it as a times r to the power n minus 1 over r minus 1. Now let's use this technique to solve the question given as find the infinite sum of x plus 2x square plus 3x cube plus so on. If we carefully see, the coefficients are forming an arithmetic progression while the variables are in geometric progression. So let's assume the sum of this sequence as Sn is equal to x plus 2x squared plus 3x cubed, and also it is given that mod of x is less than 1. That is a necessary condition to find an infinite sum of geometric progression. Now we'll multiply x on both the sides. This will result in multiplying x with x, we'll get x squared. Multiplying x with 2x squared, we'll get 2x cubed, and so. Now subtracting these two equations, we'll get 1 minus x times Sn is equal to x plus x squared plus x cubed plus so on. Now this is an infinite geometric progression. The sum of an infinite geometric progression is given by a by 1 minus r. And the reason that happens is if we carefully see the formula for finding the sum of elements of geometric progression, that contains 1 minus r to the power n times a by 1 minus r. If r is very small, that is less than 1, and n is very large, the value r to the power n approaches 0. That's why it is neglected if we are finding infinite sum. And that just becomes a divided by 1 minus r. So using the same thing, we have 1 minus x times Sn is equal to x divided by 1 minus x. Reason being, first term is x and common difference is x. So that gives us the result as Sn is equal to x by 1 minus x squared. That is option number D. This concept of AGP is very useful it's used in probability theory, in Markov processes, and physics. It's also used in physics in damped oscillations. We use the same concept or same process to solve the questions of maybe finite terms.